Hello, everybody. Good morning. Thank you for getting up so early to hang out with us. I am Crystal Harris. I am a director and Salesforce architect at CapTech Consulting. We're a national consulting firm. We do have a local Denver office. We are hiring. If you're interested, come see me, come see Shawn, come see any of those three gentlemen sitting back there. Raise your hand, fellas. We'll be happy to tell you about what it's like working at CapTech. Maybe you come join us and fit in with us. Shawn, you want to introduce yourself?
Sure. Good morning. My name is Shawn Slaughter. I also work at CapTech, and I'm a manager and Salesforce developer. I've been in the Salesforce platform, developing on the Salesforce platform for about 8 years now. Prior to that, I was a .NET developer. For me, Jest Test is important because I've been on projects where I'm working on a component and it's functioning as intended, but we don't find out until we get to the UI testing phase that we may have inadvertently broken some of the UI behavior from something else. And I got into Jest testing, and I've noticed that I'm able to more efficiently test the UI behavior prior to getting to that UI testing phase. You can build that in. We'll talk about it. You can build that into your deployment process. So today's agenda, we're going to talk about testing on the Salesforce platform. Why do we need to Jest test? We're going to give a brief overview of Jest test and what it is. Crystal's got a great demo on testing child component interfaces. I'm going to talk about writing testable code, and we've got another demo on automating Jest tests. Talking about testing on the Salesforce platform, as we all know, it's really a multi-layered approach. We all know about Apex testing and UI testing as well, but we're going to talk about Jest testing a little bit. It's a unit testing framework that's built on JavaScript through Node.js. It's used specifically to test Lightning Web Components, and the fact that it's based on JavaScript really works well because Lightning Web Components utilize modern JavaScript, so it really fits well into your developer process. It's currently not required for deployment to pass a Jest test, but it's highly recommended because, as I stated before, you could test your UI behavior upon every deployment should you need to, and you can catch those things a lot quicker and faster than somebody manually going through and testing all of the UI. Okay, an overview of Jest test. Tests run locally on your developer desktop or laptop. Jest tests are not deployed to Salesforce, and so therefore there's no access to the Salesforce backend, which is good because you don't have to worry about the interdependencies of the different components and Apex, et cetera, et cetera. With Jest testing, it's got a mocking data framework, so you can mock your own data and keep that data centralized and change it as your data model changes. Another good thing about Jest test is the tests run really fast, where especially if you're running multiple Apex tests, sometimes it can take minutes. Jest test usually just takes seconds because it's running locally on your machine. If you want to get more acquainted with Jest testing, I recommend getting started with the Lightning Web Component Test Trailhead. That's a really good place to start or get reacquainted if it's been a while since you've touched the Jest test. Additionally, the LWC recipes Git repo has several examples. Of course, as you can see, the _test_ in the LWC folder format, that's where you're going to find your Jest test. Additionally, we also, as Crystal said earlier, we're going to have a QR code with some CapTech examples as well, and also these presentation materials if you ever want to go back and get more acquainted.
So why do we need Jest tests? I'm going to tell a little bit of a story about sort of what brought me to becoming a Jest testing evangelist, I guess. We had a client, and what we built for them was this really rich, really nice mobile-friendly experience site and experience cloud. And we use a ton of custom Lightning Web Components. I don't think there's a single out-of-the-box Salesforce component in that site. So lots and lots of JavaScript, lots and lots of very dynamic behavior and user interactions. The upside of this is the users loved it. They loved it was mobile-friendly. They loved that it was really intuitive to use. The other thing that they really loved is because Lightning Web Components are so easy to create, you can deploy them really fast, they were starting to see their feedback show up in the production environment a couple weeks after asking for it. And it started to really repair a lot of broken trust with our customers. They started to get excited. They started to get excited about giving us feedback. The problem where things started to fall off the wheels a little bit is because we were going so fast, we stopped doing full regression testing. We were only testing the new capabilities. And what we started to see is we started to see a destabilization. We started seeing bugs show up where we were regressing the system. And so we had to go back to doing full regression tests as part of deployments, which meant we were batching up a bunch of stuff. I don't know if anyone here works in an agile environment, but the #1 killer of speed is bugs. So we had to slow down, and that's where Jest testing came in. We actually started with just taking our most fragile components, the ones we were breaking all the time, and built some Jest tests around them. And what we saw is a significant reduction in the number of defects that we introduced. We also were able to get back to that fast speed. So we went back from it taking weeks, mostly usually over a month, to get even a small change out, to being able to get small changes back out again within days, right? Depending on how big the change was. And so from there, it's become part of our definition of done. If you write a Lightning Web Component, you have to write tests. If you fix a defect in a Lightning component, you have to write a test for that defect. And it's saved us a tremendous amount of time and rework and has helped us regain that trust with our end users. So if any of that resonates with you, definitely look into writing Jest tests. Definitely come talk to me. One of the reasons why we have this presentation is I found that Trailhead doesn't have a lot when you're talking to getting somewhat sophisticated with Jest tests. So we had to learn the hard way, which is why we make this code available, because I couldn't find it anywhere. All right, and if you're like me, I love a good cut and paste. Shawn, you want to give us some tips on building good Jest tests?
Sure. We'll start with making testing easy. When you're writing a good Jest test, you want to focus on the unit of behavior that you're testing and not necessarily the intricacies of the code. Another good thing is starting out with writing testable code. We've all heard of test-driven development. So you want to make sure that that way it makes sure your code is more maintainable, reliable, and scalable. For Jest testing, you can simplify your test by mocking child components. That way you're able to test your behavior in isolation without any interference from outside influences or outside dependencies. Additionally, you don't want to forget to test the events that your components fired. You want to make sure that all those events and the interfaces and the results are what is intended for the behavior of that particular unit that you're testing. Automate discipline. You can automate Jest tests as a part of your deployments. It's not required by Salesforce, of course, but you can implement this into your CI/CD process. You can utilize test coverage thresholds. When starting out, of course, you don't have to go up to 90%. If you want to get comfortable, you can set your threshold in your CI/CD process. That way you're not really just overwhelming yourself or overwhelming your team. And then as you get more comfortable, you can raise those thresholds.
Shawn mentioned one of the ways that you can make your tests easier to maintain, writing good Jest tests, is using mocking to mock your child components when you've got nested Lightning Web Components. But before I get into the demo with this, I do want to talk a little bit about, we've mentioned the word mocking a few times, and if you've not done a lot of test automation, you may not know what we're talking about. In essence, mocking is creating a fake version of something that you're dependent on, such that you can really sort of control the inputs that it sends back to you from a test data standpoint. So if you think about setting up test data, it's very similar to that, except instead of putting data in a database, you're creating a fake version of something that you can control the data that comes back from. And so if we take the example here on the right, I have a parent Lightning Web component, and within it, it has a child component, right? And that child Lightning Web component has a button. When the user clicks that button, it fires an event back up to the parent with a message in it, in this case, hello world. The parent displays that message. So this is a pretty simple use case, right? When you're testing the parent Lightning Web component, what you really want to test is just that when the child fires an event, the parent does the right thing. You don't want to have to worry about how to get the child to fire that event. In this case, it's fairly simple. It's just a button click, not a big deal. But imagine if this was 15 or 20 clicks that you had to get through. Now, in order to write your parent test, you're basically testing the child. And God forbid something changes in that child component. Now you've got that change has a ripple effect. And that's usually where I find that people stop testing on the UI side, because every change requires this massive, for every one line of code change, you've got 20 lines of test change. Nobody wants to be bothered with that. So mocking comes in to show you, to help you reduce that dependency, right? So you can focus on testing the parent and not the child. So I'm going to get into a demo, and I am not silly enough to try and do a live demo, so this is absolutely recorded, of what this test looks like. So I'm going to start with what it would look like if you were not using mocking, and then I'm going to walk through how you would change that to use mocking to your advantage, right? So I have this test class for the parent Lightning Web component. It's a Jest test. And the first thing that you're going to notice is I've got a bunch of Apex importing and mocking here that only exists because the child component calls this Apex class to get the message that it's supposed to send, right? So it's calling demo Apex class dot say hello to get it. Shawn mentioned earlier, Jest tests do not have access to the backend Salesforce, which means they don't have access to Apex classes. So you have to mock the data that's coming back from that Apex call. So that's what that next line of code is. In addition, since we're mocking, I actually have to set up the test data that we're going to mock with. And then I have to click the hello button before I get to the thing that I really want to test, which is making sure that my Lightning Web component shows the right text, which in this case is howdy partner, and my test state. So inherently, there's nothing wrong with this. It works. If your test is simple, go ahead and do this. You don't necessarily need to worry about mocking. But what happens if, right, my teammate goes into the child component and they change the label of that hello button to talk button, right? They probably go in and fix the test for the child component, pat themselves on the back for a job well done, and then leave for the weekend or vacation, right? Now I come in and I'm running my tests, and now all of a sudden my tests are failing. Why is my test failing? Because I'm looking for a button that has a label hello button. So now I'm mad because I just spent a whole bunch of time on a wild goose chase for something I didn't even change. So then my teammate comes back from vacation, and I might be petty about it and make them change it back. Now, they're going to probably be like, Crystal, you are being ridiculous. It's 4 letters you have to type. Stop being annoying. What if, however, this child component was used in 10 different places? Now I got to go find all 10 places that it's used and change it. Now you're really in trouble because, you know, I'm not just mad at you. There's 9 other people that are mad at you too, right? So let's bring mocking in to save me and my coworkers from having a fist fight. All right. So to create a mock, I don't have fist fights at work, I promise. I'm going to create a new folder called mocks in my child component. And then I'm just going to take the JavaScript file, my real one, and copy it into that folder. I mentioned I like a good cut and paste. And then I'm going to delete everything out of that component. So now I have an empty Lightning Web component. You don't get any simpler than empty. All right, okay, so now I don't have to worry about Apex. I don't have to worry about any setup or anything like that. I've got a super simple one. So how do I use it? Well, the first thing I'm going to do is delete all this stuff that I don't need anymore because it's only there because of the complexity in the child component, right? Loading the data up, mocking the data, even clicking the hello button, I don't have to worry about, right? I can delete that test file because I don't need that test data anymore. So how do I use the child component, the mock version of it? All right, I want every one of my tests in this case to use the fake version of the child component. And so all I do is just.mock in the name of the component. Now all of my tests are going to use that super empty fake one. So you may be asking yourself, well, how do you get it to fire an event? Because it's empty, girl. Well, what I'm going to do is I've already, in line 31 here, you see I have the child component. I've selected that off the DOM. All I have to do is tell it to fire an event. And it is as simple as child component.dispatch event and this mock event. Right? Now, I haven't defined what this mock event is, right? But this is the test data that I want to test the scenario of. So the first thing I'm going to do is go into my test folder, or my data folder, and I'm going to create a JSON file. And I'm going to put in it the JSON representation of the event that the child component is going to fire back, right? It has a message. In this case, the test is howdy partner. I could change it to be empty. So if I test how it behaves when it's empty, I could put some really long one in to see how it behaves when there's a really long message. Once I have that, I just have to load that data in to memory. So in this case, I'm using the require method to just load that JSON file up. So I have that content. And then I'm going to do something that looks very similar because it's probably in the child component somewhere. I'm going to make that mocked event. And to make it, I'm just going to create a new custom event. It has the same name that the child component would be sending it up with. And it has my loaded up test data in it, right? And now the child component is going to fire that mocked event. If I run my tests now pass. And I am now protected from any changes that someone else may make. Whoops. We went all the way back to the beginning. Any changes that happen in the child component now, I don't care. As long as that child component adheres to the contract that it is going to fire an event with an attribute called message that has a string in it that I'm supposed to display, how it happens, I don't care, right? No more fights on my team. So I did mention that that component needs, the child component needs to adhere to its end of the contract. So there's the other side of this testing. Typically what you'll see is when we write tests, we focus on this stuff that's happening inside. If you have a LWC that fires an event, you want to make sure that you write tests to make sure that those fired events have the content that they're supposed to have in it, right? So you're testing that the child component adheres to its end of the API, as well as the parent component is adhering to its contract within the API. Shawn, let's talk about writing testable code.
We're going to talk about, first we're going to talk about this quote from Vladimir Korokov. Tests shouldn't verify units of code. Instead, they should verify units of behavior, something that is meaningful for the problem domain, and ideally something that a business person can recognize as useful. I like this particular quote. I think he's just talking about the shifting the perspective from looking at it from testing the intricate lines of the code to testing more behavior-driven based on the outcomes that your users and your stakeholders are expecting. So basically testing the what and not the how. Writing testable code. As Crystal showed us in her wonderful demo, you can import mock data and keep that data centralized in a data folder. And of course, you can make those changes to that mock data, those JSON files as your object model changes, whatever the case may be, because it runs locally. It's not anything that's stored in Salesforce. Using local state to capture errors and notify users. Speaking on that, it's actually, this is what makes it really important to leverage HTML data attributes to provide unique identifiers for elements, because that's how you're going to better be able to notify your users of what the error is and where the error is. So those are just some tips on how to write testable code.
I'm going to go through this really, really fast. So Apex today requires you to have tests and they pass before you can deploy, right? And that builds discipline in. We want to have that same discipline built in when you are using your Jest tests. You could buy some very expensive tools. Some of those people are outside right now. But if you don't have budget, you can do what we did, which is I just wrote a basic shell script. And it's pretty simple. It takes in an environment variable. It has some error handling. And then it gets into the sort of meat of it is it runs my Jest tests, and then it does a Salesforce deploy with a manifest, a package XML manifest file. And what that looks like is I run the command, I give it the environment. I happen to make one here for TDX. And it just runs. So when it runs the Jest test, so you can see those passing the top there, and then when it's done, it runs the Salesforce deploy. And it's really that simple. I would say there's one tip when you're doing this is make sure that if your Jest test failed, that your script does not continue on with the deploy. You want it to stop there, just like Apex testing does. And with that, Shawn, you can tell them about getting started.
Okay.
60 seconds.
Okay. Utilizing version control, your Jest tests are going to be, you're going to want to store it in your GitHub repo, again, since it's not stored on the Salesforce platform. And that makes it better to iterate and keep your versioning the same with your code. As Crystal showed us, you can start out with a basic shell script. You can run the Jest and deploy the change set, and you can set those coverage thresholds to whatever you want. Because again, this isn't something that's required by Salesforce, but highly recommended. And to help with adoption, you can make sure that Jest is part of your definition of done for each feature for Lightning Web Components. And of course, talking about those thresholds, you can periodically assess and raise those thresholds as you get more mature and comfortable in the process when you're implementing Jest testing into your development workflow. We'd like to thank you from CapTech. Appreciate you. Hopefully you didn't drive through too much traffic this morning. Here's the QR code we were talking about. You can scan that QR code and get access to our presentation materials and our CapTech GitHub repo with examples. We'd like to thank everybody for joining us. Crystal?
Thanks for hanging out with us, guys.